This video is going to discuss solving a rational equation. Okay, remember rational expressions are fractions that have variables. So now we're having fractions that have variables with equations, so rational equations. When we're solving these particular equations, we need to do one of two things. First, we have to find the excluded values. So remember from a previous section, we need to find excluded values, right? We talked about what they were, how to find them. In case you forgot, we're going to kind of go through this and figure out what to do here for excluded values. So remember, excluded values are numbers that make denominator 0. So if I come back to my equation now, which is up here 2 minus and then a 3 over x fraction equals 1 over x. I want to find the value of x, okay, such that it's true when I plug it in. So remember I talked about we make the denominator 0. So what number would make this x 0? Well, 0. What number would make this x 0? That's 0. So my excluded values are x cannot be 0. Okay, also remember that I take the denominator and I set it equal to 0. And I solve. I can't solve anymore because x already equals 0, so that's how I get 0. Also, remember we talked about if it was a monomial, that excluded values are always going to be 0 and nothing else. If it's a monomial, you get 0. Now, what would happen? Technically, I have a 1 underneath my 2. I can't turn that denominator into anything because it doesn't have a variable. If it has a variable, then I need to find the value. If there's no variable in the denominator, then I don't have to worry about it. Okay, so that's the first part, is find excluded values. So we did that. Excluded value here was 0. Step 2, I need to find LCD. Remember, LCD is least common denominator. We've talked about numerous times that you don't necessarily have to find the LCD. You can technically find a common denominator, so anything that they go into, whether it's larger or the least one. It's just, if it's larger, then you're going to have to simplify more. And we talked about strategies in order to do that. So find the LCD of all fractions or terms. We're going to go with terms. So coming back to my original problem here, 2 minus 3 over x equals 1 over x. This 2 is technically over 1. Okay, so what I'm going to do is I'm going to, underneath this particular equation, I am going to write the problem over again. And if I look at my denominators, 1, x, and x, what is my common denominator? Hopefully now we've done this numerous times, or different parts of finding common denominators. We all realize that it's x. Because this x and this x are the same, my numerator stays at a 1. This x and this x are the same, that numerator stays at a 3. This 1 to that x is being multiplied by x. So I have to multiply 2 by x to get 2x. Okay, just like we've done in the past. Multiply the top and bottom by the same thing. You're not changing the value of that of that fraction. It's an equivalent fraction. Now, here is kind of a neat thing about rational fractions, rational equations here when I have an equal sign there. Just like we did in a previous lesson, because my denominators are all the same, they wipe out. So step 2 was find LCD of all terms. Step 3 is to basically cross out denominators and solve remaining equation. So there you go. Those are your 3 steps. So now I crossed out my denominators. What am I left with? I'm left with 2x minus 3 equals 1. I add 3, so I get 2x equals 4. I divide by 2, x equals 2. So I have x equals 2, and that is your answer to the equation. Basically what happens is if I were to plug 2 into all of my x's into the original equation, I would get a valid equation. One side is equal to the right side, the left side is equal to the right. Now, you might be like, well, what's the excluded value have to do with anything? If you look at the instructions, This is a part I did not discuss at the beginning because this is really where it comes into play. Extraneous solutions. Okay, here's what extraneous solutions are. They are solutions that when you solve an equation, you get, but if they match with any of your excluded values, they don't actually work. So what we just talked about was the extraneous solutions. I know that was kind of complicated, but so here's another kind of different way to think about it. If the solution to the problem, or solutions to the problem, the equation, right, because our equations could have more than one, if our solutions to the equation have an excluded value in them, then the solutions that are the same as the excluded value get crossed off. It's not considered a solution. Okay? We'll get to some of those examples here coming up. But that's what an extraneous solution is. If an excluded value matches one of your solutions, then it just disappears. Then your solution is only the one that's left, or ones that are left, depending upon what you have. So this 2 is different than that 0, therefore my solution is 2. Okay, it is 2. So let's go to another one. I'll leave the rules up here so you can kind of look at them. Okay, let's look at this equation up here. You'll notice I have a binomial in the numerator, some monomials in the denominator. So the first thing I want to do is I want to find my excluded values according to the steps on the right side. So because this is a monomial, I get 0 for all of them. So excluded values are x is equal to 0, or it can't equal 0, right? Next thing, step 2, is find LCDs. So LCD, if we look at them between a 3, a 1, and a 3, the LCD is a 3. Numerical value is a 3. Then I take the highest degree of my exponents that are there. So because n's are all the same and they're all just straight up n, so it's 3n in my denominator, for my common denominator. So because this was a 3n here, this still becomes a 1. I had to multiply this by 3, so 1 times 3 is 3. The 3n here stayed the same, so that makes that an n minus 5. Your third step is, remember, it says cross denominators out, and then solve whatever's left. 1 equals 3 minus n plus 5. Some of you are like, well, how do I get a plus 5? This negative is distributed to that binomial. We've done that before. So now I solve. I can combine terms on the right side. 3 plus 5 is 8 minus n. Bring the 8 over. I get negative n equals negative 7. And flip n equals positive 7. Since that solution does not match an excluded value, then this, we know, is our answer. I don't have to cross any of them out. That is our answer, n equals 7. Go ahead and pause the video to try to figure out this particular problem, and then press play to find the answer. All right, let's look at excluded values. This excluded value is 0, 0, 0. Since they're all the same, I only have one excluded value. X cannot be 0. Common denominators. N squared, the highest degree of your variables. So n times n, so that makes this a 6n. The n squared here stays the same, so it's n minus 3. This n squared stays the same, so that's a 1. Step 3, cross off denominators. 6n equals n minus 3 plus 1. 6n equals n minus 2. 5n equals negative 2. Remember, I subtract the n's. Divide. N equals negative 2/5. What? A fraction? It is okay to get a fraction. It is fine. It is math. This answer, solution, doesn't match my excluded values, so we know that it is the answer.